Report. Very much. You should see a recording button now. All right. Thank you, everyone, and welcome to the Financial Services User Group. On June 15th, we have an excellent collection of people joining today, and thank you for everyone who's joining. We're recording this, so if you're watching this recorded, thank you for watching us as well. Today, we're going to take a look at multi-cloud security in a zero trust world and best practices around using Vault. Please don't hesitate to put some questions in the chat. We'll be able to address them as they come or towards the end of this session, and we'll have a panel for discussion at that time. All right. My name is Ilya Vinnik. I am a global success manager with HashiCorp, focused on financial services and financial industry customers. Online with us today, we have Hope Blaythorne, who some of you probably know if you've been to our past events or read anything about customer success and on LinkedIn, because Hope is our global segment leader for HashiCorp and customer success. We also have with us Guy for EMEA and HashiCorp, and is a technology executive with many years of financial services background. He's based in London, and he has previously held roles as an executive director at JP Morgan, as well as roles in Deutsche Bank, Goldman Sachs, and some of the other well-known organizations. Also online with us is Dan McTeer, who is a strategic technologist at HashiCorp and assists our largest customers with the security-related portions of their multi-cloud journey, providing guidance on how to deploy and manage and integrate with HashiCorp Vault. He's also an author of Running HashiCorp Vault in Production book, which I encourage you to check it out. And also, last but not least, is Kawsar Kamal, who is our staff solution engineer and has been with HashiCorp for a number of years and supports some of our top FSI customers in New York Metro on their HashiCorp journey. All right, thank you, everyone. And again, welcome. So, oops. A bit of a delay in the slide change. Apologize for that. You'll see also our social media information here. You can reach us on Twitter or LinkedIn, and we welcome questions and connections, and are happy to connect with our customers and potential customers. All right. For our agenda today, we're going to take a look at the Zero Trust. A guy will run us through an overview of Zero Trust, and then we'll take a look at an example of what an FSI customer adoption looks like, and take some questions and have a discussion about what we are seeing out in the field. You'll be able to ask questions, like I said, please put them in the chat or reach out on email or on via interface. All right. And with that, I will pass it on to Guy.
Thanks, Ilya. Okay. Do you mind stopping your share so I can do mine? Thank you. All right. I'm going to take maybe between 10 minutes and around that. And I will mostly cover, our philosophy for Zero Trust, and then briefly touch on our products for implementing Zero Trust. And then I want to show a nice blueprint that kind of puts this whole thing together and kind of moves from a theoretical pie in the sky to how this could be achieved before we go to real life examples. So this is, there are a few slides which I'll use from our Zero Trust talk. I'm not going to do the whole thing. It takes about half an hour. There are recorded videos of it, and we do it in a few Zero Trust strategy days, mostly in EMEA. Feel free to join the future ones. But I like the slides, so I'm going to borrow some of them. So when we think of Zero Trust, we kind of look at 4 different areas. And I want to cover the machine-to-machine and human-to-machine authorization, authentication, and then separately the access. The overarching principle is moving from traditional physical IP-driven controls to identity-driven controls. So think about the long-running, well-known, statically provisioned compute and infrastructure that sits behind network gear that is fully controlled on-prem, typically, to a world where we consume from cloud providers and don't necessarily know how things are implemented, let alone be able to control and dictate how they would be implemented. And in this world, not only everything is dynamic, we also want to overlay modern architecture and development practices, and move fast, microservices, Kubernetes, ephemeral workloads. So we're kind of moving from well-known, highly trusted, static environment, governed and controlled by IP addresses, right? IP tables, firewalls, and so on, to ephemeral, on-demand, logical identities or identity-driven controls. Right? This is kind of the overarching principle for the whole zero trust strategy that we present. And then in each of these boxes, we have a product that we'll cover quickly. And I'm going to start with kind of skim through the slides, right? The human-to-machine identity, this is single sign-on. We don't implement single sign-on, we integrate and leverage single sign-on, right? So it's very quickly to move on. And then looking at machine authorization and authentication, this is where Vault comes in, right? And in brief details, the guiding principle for Vault in Zero Trust is this whole notion of identity brokering. So you're going to Vault with a well-known, trusted identity, and after authenticating, Vault will broker, will create on-demand ephemerally identities and credentials on target environments, be it a cloud provider or a Kubernetes cluster or a database, and so on. Next, we talk about the machine-to-machine access, which is where Consul fits in. Consul is our networking solution. And it has a notion of crawl, walk, run in terms of adoptions and use cases. Right? So we start with discovery and enhance it. In the context of Zero Trust, we're talking about application-based networking. So, think about, logically speaking, a firewall rule saying this IP is allowed to talk to this IP. And then in the console language, it's this service allowed to speak with this service, regardless of IP addresses. And when IP addresses are provided, when the model is realized and changed due to whatever physical changes, reactive or proactive, those rules don't need to be updated. Right? So we're moving from physical, static, well-known IP addresses to something that is more dynamic, but the policies are going to be at a logical service-to-service, application-to-service level. And human-to-machine access, right? This is where we introduce Boundary. Boundary it's a new product. It's available as open source. It basically solves the problem of on-demand, break glass access to resources and compute on the network. And I kind of explained the traditional workflow and all the fragility with being static, IP-based. Credential needs to be exposed. Users need to be known at the resource. VPN keys, physical devices need to be distributed. It's also it was good, it is still good for well-known, static, slow-changing environment, right? And Boundary kind of scratch that and think about the problem from scratch. This is where we integrate with single sign-on, and we use role-based with high-level rules for services and create something that you can think about as logically speaking as an SSH tunnel between the user endpoint, user laptop, and the resource, and leveraging console to create the identity and credentials dynamically. And then when this thing, the session completes, this whole thing collapses, and there's no way to attacker to take advantage of the network. Kind of go through the HashiCorp, the boundary workflow. And typically I kind of conclude here with our zero trust presentation, right? So I covered the 4 boxes. Again, just to repeat, our overarching principle is moving from static, well-known IP-based control, network IP-based control, to modern, dynamic, ever-changing service and application identity-driven controls, right? So that part is done. And I want to now use a slide from this presentation. This is not mine. I didn't make it. I need to give credit to my colleague, Lance and Nico, actually, for making this slide. And kind of puts this whole thing in a nice small diagram, right? I want to see some. Oh, it has a flow, but I'm going to fast forward and kind of talk through that because I'm not going to do the entire flow, right? So we put on a single blueprint, we have Vault, Console, and Boundary creating this ecosystem. And what we see here is basically an application. It's a Go application here on the left, databases here on the right. The application takes input, sensitive input from a user. It uses Vault to encrypt. After authenticating and creating its own identity, it would encrypt user data. Connections between the application and the database would all be governed by the console security, right? With mutual TLS connections. So now think about all the keys and tokens and certificates that need to be automatically changed and rolled. And that kind of is all automatically done by console. And then while the application is happily running and doing its stuff, we also see an administrator sitting here, and through boundary through Vault, creating a break glass. I think this is the last portion. Break glass on-demand access to the database to debug something or whatever. We can make a story, but the idea is you can see on this blueprint how the different moving parts and relationship between application service, and then when you layer service mesh for security, Vault here for authentication, authorization, and data encryption, and Boundary to provide the on-demand break glass access for the system. I think that's basically that's me. That's my quick overview on zero trust with a nice blueprint example. And with that, I think next is Kawsar to go through some real life experiences and example.
So thank you, Guy. That's great. Yep. Next is Kawsar. We're gonna go ahead, and you guys should be able to see my screen. Somebody nod that we're back to the agenda slide. Thank you. And we're going to take a look at what a real life user example here looks like for a financial services customer. Kawsar, I'll pass it on to you.
All right, thank you, Ilya, and thanks, Guy, for that overview. Oops, I think can you all hear me okay, Ilya? Just making sure. Okay, perfect. Yeah, so as Guy was already mentioning, Vault comes in and can do identity brokering for applications. And if you know Vault, right, you may know that Vault has many different ways to authenticate machines, right, or any clients, whether that's machine or human beings, by the way of authentication methods. And Vault can service many different types of secrets, right, whether it's key value secrets or dynamic database credentials, cloud credentials, or PKI certificates, etc. So this is just one use case that I have worked with in a large financial institution, and that's what I wanted to talk about in the framework of the zero trust security model. So if you want to move forward, Ilya, on the slide. Okay, great. So this is a legacy sort of financial institution. They have a large technology footprint. that they're carrying, and as a result, they have lots and lots of virtual machines, right? So many of us are in this scenario from an organization perspective. We may have thousands to tens of thousands of virtual machines, and we need a way to sort of SSH effectively into these machines. Now, the typical solution, right, is to have public key authentication. So what that means is you have a public key that's on the SSH host, and then the client that's logging into the machine has a private key. And there are a few challenges that you may already know with this. One of them is long-lived credentials. So whenever you have this private key model, you have, AWS, for example, gives out what's called a PEM file. And these PEM files don't really have any type of time limit associated with them. And that's problematic from a secrets management perspective. You may also get sort of PEM file sprawl. So these files may appear in all kinds of places like file system, object storage, etc. The next big challenge is that it's difficult to audit, right? So as long as somebody is presenting the private key, the SSH server is going to allow that person or that machine process to log into that machine. And from a zero trust perspective, this is especially problematic because you don't really know ultimately who has the private key, right? So the entire thesis of zero trust is that there may be some malicious entity that's already on the network, right? So this kind of, if you have these private keys that are sprawled within your network, they may get passed around, and there isn't really a good way to know who is using this private key to access the server. So it's also, if that person leaves the company, then it's going to be very difficult to kind of remove access, right, if that person still is holding on to the private key. Essentially, it comes down to that it's difficult to audit and govern who is accessing these machines and how. And then the last one, Ilya, if you want to just hit the next button once. Okay, yeah, so we've all seen this, right? Just raise your hand if you just type yes when you see this warning. This is a very typical warning. The SSH host says, well, we're not really sure if we should be logging into this machine. We can't verify its identity, but typically we just hit yes and move on. So it tends to break automation in a lot of cases. Also prone to man-in-the-middle attack. It's very hard to actually orchestrate a man-in-the-middle attack using this kind of scheme, but it is possible, right? Someone could technically be on your network and set up a SSH server and he kind of be eavesdropping on your communication. So Ilya, if you want to move to the next slide. All right, so an alternative way to perform SSH authentication is to use sort of this notion of public key cryptography, but take it a step further. So we all know kind of how we have a general sense of how PKI works, right? SSL certificates when you log into a website or when you visit a website, the certificate that the web server presents is signed by a certificate authority that you trust. And the same principle can be applied in terms of SSH access. And it's actually a very sort of tried and true and mature way to scale in terms of SSH access. And there's all these links here. We'll share these in the meetup page. Just as a disclaimer, these companies are not necessarily using Vault, right? They may or may not be, but they've just written about their experience in using signed SSH certificate as a way to scale sort of, logging into tens of thousands of VMs and, doing that in a sort of secure way. So we'll just kind of leave that here. If you want to go to the next slide. All right, so let's talk about kind of how Vault uses the signed certificates principle, right, to enforce sort of SSH access, right? So in this diagram, the use case here was machine-to-machine authentication. So when Guy was showing that kind of slide with the 4 different boxes, the very first one talked about machine authentication and authorization. And a software that really needs to have sort of SSH access to lots and lots of machine is Ansible, right? Configuration management. It could be any other process as well that has a need to SSH into a server and do some type of work. So in this case, right, the workflow is the process will log into Vault by proving its identity using any one of the authentication methods. It will request a public key that will be signed by Vault SSH CA. So Vault will be that certificate authority. The signed public key will be returned to the user. And then the user will authenticate to the target host by presenting the signed certificate that Vault has provided the user, right? User or machine. So in this case, it could be a Vault client, right? Human beings could also go through the same workflow. They would probably log in using an authentication method such as LDAP or Active Directory, etc. So real quick, just wrapping this up, right? Some of the challenges that we mentioned before was that certificates or SSH credentials tend to be long-lived. So in this model, you can really time limit the credential to access that target host. So it could be as small as 1 minute. You just need the credential to be long enough to make that initial SSH connection, and then you're good, right? So at that point, if somebody gets a hold of this signed public key, it's no longer good. That the time of validity is always sort of moving. So short-lived credentials, a very well-known Vault principle. The next one is auditing. So Vault has a very comprehensive audit log. Which entity is coming in and logging in at what time and what type of secret it is requesting. And you can also correlate Vault audit logs with the SSH server audit log to build sort of that comprehensive story, right? Who's accessing which server at what time and how are they accessing it? And the third thing, like the host key verification, if you use the Vault SSH CS secrets engine, you can put the signer certificate on client machines. And this way, so that machine is, that entire process is trusted, and you will no longer get that warning, and you can confidently kind of log into your target host, right? So just wrapping this up, this is just one use case within the overall Zero Trust security framework for machine authentication and authorization. So Guy, I'll pass it back to you for the next part of the agenda.
Yeah, thanks, Kawsar. So, we kind of went through a lot of content, right? A little bit of theoretical, where we fit, strategy, static, dynamic, and all that fun. And there's a lot there, right? We appreciate that. We want to kind of pause and open for questions. For anyone from, questions or things that people would like to talk about, share.
We do have some questions, Guy,
Oh yeah, okay.
that Ilya captured beforehand, and we could jump off with those.
Sure.
Thank you, Hope. So we got a couple of things that we've captured before, as Hope mentioned. Some of the questions are sort of what is the value of Zero Trust technology and this process for our financial services organizations, right?
I mean, I can give my perspective.
Sure.
So this probably applies to large enterprises anyway, but within FSI, for many years, systems, applications, and infrastructure were all deployed with high degrees of controls, all behind physical walls, castle and moat model, fully focused on the ingress, with the strategy of anyone that's inside is good and trusted, outside is bad. And we have accumulated technical debts and issues, security issues, kind of lingered throughout the years. And we knew it's not completely safe. We know that applications and infrastructure on-prem, if you gain access, then all bets are off, right? Because some things don't even do any authentication, and some just check that there is a valid cookie, and things like that, very, very basic. The value on top of everything that we talk about with going to cloud and kind of cloud putting this in the forefront and making sure that you can no longer it's not good enough. You can no longer treat security as a gatekeeper at the end and ignore the findings. On top of it, it removes a lot of these risks that organizations have accumulated, right? That's for me, that's the #1 value of zero trust: the enablement of cloud, but also removal of years of technical and risk debt that we have accumulated.
I don't know if anyone wanted to chime in. Anyone else wanted to chime in? But I will say that it helps remove the barriers to adoption. It helps move things faster into the production, and it allows our customers to get to good and great faster and be able to implement and serve their customers better. Right. So that's the bottom line.
Yeah, I see a question. We can take this question. We hear a lot about ransomware in the news, right? How would zero trust have helped in some of the recent attacks? That's a nice one.
That's great.
Anyone wants to go? I can go.
Yeah, go ahead. Go ahead.
So, the thing, right? I mean, broken windows and everything. Attackers, cybersecurity, it's an evolving, it's not a static set of threats. And, cyber organizations and attackers they are getting sophisticated by the hour, right? And I read somewhere something that resonated, right? And if you think of CVEs, right, and the shift from CVEs being the main area of attack surface or attack vector, to APIs and kind of attacking existing applications as being one, because of that lack of authentication and authorization. And I think, there are so many things when you think about security and cyber and zero trust even. We solve the application and infrastructure on the data center with all our vault and console and boundary. There's stuff right to us or left. This is left. Yeah, the other left. API security and the things that are happening before you get to our level. When you think of ransomware, if you think of using console and vault to secure application service-to-service authentication and access, this is where we would limit and block ransomware from kind of taking advantage of these holes. But I think, like, outside of these areas, we really need to expand and talk about ransomware more broadly, right? Because if there's an agent that has somehow made its way to the network, right? Think about it that way. You used to be, if you are on the network, you had access to stuff. On the network now, because of implementing zero trust and you don't have access to anything, your presence on the network is completely meaningless until such time that you have properly authenticated, you establish identity, and then you can operate. So from that perspective, if I think and try to kind of derive ransomware to our discussion, this is where it would help, right?
Yeah, so I just want to add to that real quick too. Most ransomware attacks occur through, things like email, people opening infected emails or going to infected websites or things like that. So, part of the real problem when you're talking about, your critical systems that are storing your most critical pieces of data, generally speaking, like Windows systems are usually hit with ransomware attacks more than Linux systems are. But, probably one of the keys to protecting yourself, first of all, is, making sure people aren't accessing emails or accessing websites from some of those machines. And tools like Boundary, for instance, will be able to help protect against those things, because you can actually apply rules as far as what a user can do once they're connected to a system. to kind of prevent that at the front end, so to speak. So I think, you know, Boundary and a lot of other tools you see that are managing user access to these critical systems will block a lot of those things that are basically installing ransomware on hosts and spreading it out.
Yes, totally.
So,
even
yeah,
Dan, I think what you're saying is even if you manage to grab hold of credentials, and even if they haven't been revoked, and even if you were not caught, you will still be subject to role-based access and policies and stuff that is there to protect and reduce, you know, the least privilege principle, right? Yeah.
exactly. Yeah.
Yeah, I think that's a good one.
Awesome. Anybody else? Awesome. Great. Thank you. So another question we had before is this is great, but how do customers get started? Right? Like we don't necessarily know where to start. Where do companies get started with the process of implementing this technology and this is a program? Right. And go ahead, Kawsar.
Yeah, I can probably start it off, and if anybody else wants to go after me. So yeah, I really think just kind of based on working with customers over the last couple of years, especially in the FSI vertical, there's always a single sort of compliance finding or a single sort of gap in the overall security story that they're looking to mitigate, right? And I gave just one example of SSH access, right? That was probably a security finding internally. But then if you kind of look at any organization, generally like there's one pain that they have identified, which is often the starting point, right? And I can speak to Vault specifically because Vault supports so many use cases, right? A recent one that I'm working with another customer, they're trying to provision to AWS and they need a way to really provision dynamic AWS credential and have sort of the short-lived credential. So I think it starts with that sort of that single use case or like the highest pain point that you're trying to mitigate from a compliance and governance perspective. And that's where you kind of bring in one of these products, something like Vault to provide identity brokering and provide sort of short-lived secret. Then I think it kind of goes from there, right? And then you have to kind of step back and say, okay, so I've addressed this one challenge, but how does it sort of fit in my overall sort of secret zero or zero trust model story? So I think that's kind of the simplest way I can put it. Just in terms of Vault, all of these other tooling will also have sort of their initial use case, right? And what is kind of the entry level problem that product or technology is trying to solve. And then once you kind of get that in to mitigate that challenge, you kind of zoom out from there and address some of the other kind of larger concerns.
Yeah, I think I'd echo that, Kawsar, and I would just extend it and say there are things that you can start with applications and infrastructure on-prem before you do anything cloud, right? Just kind of driving hygiene and what Kawsar said, right? Moving from hard-coded or config-based, long-lived password, roles and responsibilities on databases and resources. These are things that can be done as preparation for your zero trusted network for multi-cloud setup.
So,
all right.
Any comments? Anything else from the? Okay. Cool. I think I can you guys can unmute and chime in if you want, or post any other questions. We can have like a minute or two of an open forum, but I think we're good with the questions that we've had and the presentation. I want to thank our panel and everyone who attended, and we can go ahead and wrap.
Thanks, everybody.
Thank you. And please do follow up if you have any questions at all. If you want to reach out to us and connect, and please engage and connect and reach out. We're happy to help our customers.
If because this will be distributed, and if someone is watching the recording, like it's very easy to get hold of us.
Yep.
Feel free.
We're very
Join a
excited.
future session or whatever else, right?
If you're watching a recording, please join our next session live, where we'll take questions and suggestions for our next topics. Again, reach out, and thank you very much.
Thank you,
Bye,
guys.
everybody.
Thanks.
Bye, everyone.
Bye.
Cheers.